Hello class, welcome to another video for this course. In this video we are going to start chapter 7 of the textbook and start looking at section 7.1, solving trig equations using with identities. Okay, so far we solved some basic trig equations, but in this section we want to look at more complicated equations that involve trig function. And the technique is that we just need to use algebra, the techniques that we know from algebra to solve equation, and combine it with the identities, the trig identities that we learned in this course. So for example, look at this function 2x squared plus x. Okay, if you are to solve this for 0, then you simply just set this equal 0, you factor it, and then you set up each factor equal to 0 to solve it for x. So this is what we learned in algebra, and we are going to do the same thing. We just sometimes we need to factor, sometimes we need to set each factor equal to 0 or other variable. So this is not new. And for example, you also saw that if you have a basic trig function like sine and you set it equal to 0, then you can use a unit circle in order to solve it. So sine equals 0. At what angle do we get 0? So we get 0 at 0, pi, 2 pi, 3 pi, and so on. So this is what we learned in previous chapter. Now put these two together. So the equation from algebra and also the trig equation that you learned. So for example, suppose you have a composition of these two functions, function g sine and that linear function, and when you compose them you get this function 2 sine squared plus sine. Okay, so when you set that equal 0, then you just need to do the same thing. Imagine that the sine is your variable, factor it, and then solve it for sine. So that's it. The technique is that we're going to use what we learned in algebra to solve equation, plus we may need to use trig identities. And here is in this table you can see this is like a reminder or refresher of the trig identities that we have learned. So without further ado, let's see, go to the examples. And you will see how we are gonna do this in solving problems. So the first example is solve 2 sine square. So 2 sine square plus sine of t, I guess equals 0. Yes, so solve this equation for t such that for all the values between 0 and 2 pi. So solve this for t between 0 and 2 pi. So for what values between 0 and 2 pi this equation holds? Okay, so think about this as algebra. So recall algebra. When you have an equation and you want to solve it, and if there is a term that is common, then we can factor it. So look at this term. This term has sine. This term also has sine, and we have summation of these two terms. So both of them have sine in common. That suggests us that we can factor sine of t from this side. So from the first term, we end up with 2 sine of t, and from the second term, we end up with 1 equal 0. So we factored sine out. Now, this is a factorization, right? So when the product, the multiplication of two elements is 0, it's either the first one is 0, so it's either the sine of t equals 0, or the second one is 0. 2 sine of t plus 1 equals 0. Okay? So from here, when do we have sine of 2 equals 0? So that happens at using unit circle at 0 at pi, at 2 pi, and I'm going to stop here because the restriction is between 0 and 2 pi, so I don't need to go beyond that. What about here? So let's solve this. So this is going to give me sine of t equal negative half. So t is, using unit circle, negative half. Let me see. So this is sine, this is negative half. So the angle must be here, right? So it's going to be pi over, this is unit circle. This is negative half. So the angle is in this it could also be this one, right? Because this one also has sine of negative half. So this is gonna be pi over, look, because recall that pi over 6 gives us positive half. So this is gonna be negative pi over 6. And this is gonna be pi plus pi over 6. So this is gonna be 7 pi over 6. So one of them is 7 pi over 6. So one of the answer is here. In fact, here, 7 pi over 6. And the other one, you can either say negative pi over 6 or you can say 2 pi minus pi over 6, which is gonna be 11 pi over 6, this guy. So the other answer is 11 pi over 6. So we got 0, pi, 2 pi, 7 pi over 6, and 11 pi over 6 as the answer of this question. And you can see that here as well, 0, pi. Why there is no 2 pi? Oh, okay, because it says between 0 and 2 pi, nothing excluding 2 pi. Okay, so I should exclude 2 pi. Okay. So not this, we exclude this one. Okay, so that's it. This is the way to solve it. And if you want, you can also verify that with the graph. Let's go to GeoGebra and just look at the graph of this graphing calculator. So on the right side, we have 2 sine square plus sine, 2 sine square of x sine square plus sine of x. Okay, as you can see, we are looking at, what does this mean? The equation 2 sine square plus sine of t equals 0 when the graph is 0, right? When the graph is 0. And we are only looking at the interval of 0 and 2 pi. This is 0, right? This is 0. 2 pi is about 6. 6 is right, it's here. So as you can see, the number of 0 is 1 is here, which is 0. And then there are 2 zeros here, here, and here. And then there is 1 here. And that's it. 1, 2, 3, and 4. Yes, because 6 is here, right? So up to 6, up to 2 pi, there are 1, 2, 3, and 4 x-intercepts, which we also found them algebraically. So now let's do another example. Okay, now let's look at the example 2. Example 2 says secant, the question is 3 secant square minus 5 secant minus 2 equal 0. So this is the equation. We need to solve it for t for all solution between 0 and 2 pi. 0 is included, but 2 pi is excluded. Okay. So again, let's, I mean, yes, this is an equation that contains trig, but if you, because the trig function is secant, if you, let's call the secant, name it something, for example, u, just label it. So label it and then rewrite your equation. So it's going to be 3u squared minus 5u minus 2 equals 0. Then think about algebra. Use algebra to factor this equation. So this is going to be 3u times u. So this times this gives me 3u squared. Here I should have 1 and 2. Because this is going to give me 3u, this is going to give me 2u, and if they are negative, negative 5u, let me see, this times this is positive, no. So for factoring this, if this is 1 and this is 2, this is going to be negative 2u, and negative 3u is going to be 5. So I'm not sure about the sign. Let me see your textbook. This is positive, this is negative. Okay, this is positive. Let's see. This is negative. Okay, but then this isn't gonna give me the 5. Let me see. 3u squared minus 5u minus 2. Okay, let's see. This is gonna be 3u squared minus, yes. 3 times 2 is gonna be 6u, and then plus u, and then minus 2u. No. Wait. Minus 2. So this times this, and then this times this is 6u. This times this is u, and this times this is negative u. So I guess that's an error in your textbook, because this is, no, that's right. My bad. Yes, that's right. This is minus 5u minus 2. That's right. The factorization is correct. Yes, that's the way to factor it. And then you set it equal to 0. Now either this factor is 0 or the other factor is 0. And then you solve it for u. Okay, and then you solve it for u. So u is gonna be negative 1/3, and here u is gonna be 2. Okay, now what is u? Okay, now we solve this in terms of algebra. Now let's involve the trig part. U is secant. So we are saying that either secant is negative 1/3 or secant is 2. So now we can solve it for t. So what is secant? Secant is 1 over cosine. So if 1 over cosine is negative 1/3, that means the cosine is negative 3, which is doesn't make sense, because cosine, recall cosine. Cosine is a function between 1 and negative 1. It never reached beyond 1 and 1. So cosine is not, this is not acceptable, or it does not make sense, because cosine is never more beyond 1 and negative 1. So that doesn't give me anything. But what about here? Here, 1 over cosine is 2. So cosine is half. Okay, that gives me something, because we know that cosine can be half. Using unit circle, cosine is half. This is half. For pi over 3, so this is pi over 3. And also for this angle, right? Which is negative pi over 3. So pi over 3 and negative pi over 3, or in other words, this is going to be 2 pi minus pi over 3. So 6 minus 1, 5 pi over 3. Okay, so that's it. These are the solution to this look. So for this equation, we first labeled secant as u, and then we treat this as algebra, solve this algebraically. And then finally, we again incorporated the trig part to solve it for t. So the answer is pi over 3 and 5 pi over 3. You can also look at the graph to see, to verify your work. Now let's look at another example, example 3. Example 3. So the question is solve 2 sine square of t, 2 sine square minus cosine equal 1, and find all the solution between 0 and 2 pi. So t between 0 and 2, oh, no, 2 pi is excluded, 2 pi. Okay. So in this case, look, so far in the examples we saw, let me show you the example one more time. In these two equations, for example, in the first equation, it only contains, the equation only contains sine, so I factored sine out. The second one only contains secant, so I factored secant. But this is a little different because it contains sine and cosine. So there's, I mean, when you look at this, you don't see anything in common to factor, right? So here is the place that we can use identities, the trig identities. And in fact, I would like to rewrite this equation in a way that it is only based on one of these trig functions. So you know, the ideal case is when you have an equation that it's only based on sine or only based on cosine, not a combination of both. So I'm going to use this identity. Look, this identity. Sine square is 1 minus cosine square. If you want, I can rewrite it here as well. Look, we know that sine square plus cosine square is 1. So we can rewrite sine square as 1 minus cosine square of t, right? So here I'm going to rewrite sine square as 1 minus cosine square of t. So 2 times this minus. Okay, now I have an equation that only contains cosine. So let's simplify. So this is going to be 2 minus 2 cosine square minus cosine equal 1. Let's simplify a little more. Negative 2 cosine square minus cosine. This is also 2. Negative 1 equals 0. I would like to factor this as first I would like to multiply this by a negative sign. So multiply both sides by negative sign. Now factor it. So this is gonna be 2 cosine times cosine. And then this is gonna be 1 and 1, right? And then this times this gives me 2 cosine square, 2 cosine, yeah, 2, this must be positive, this must be negative, because 2 minus 1 gives me positive. Yes, I think this is the way to factor this. Now, because this is 0, so it's either the first factor is 0, either the first factor is 0 or the second factor is 0. Now solve it for t. So this gives me cosine is half. So t is pi over 3, 5 pi over 3. Yeah, and cosine of t negative 1, which gives me negative 1 is pi, because it says only between 0 and 2 pi, that's the only answer. It's negative, it's pi. So these are the solution to this equation, right? So we factor it and we get cosine is half, which gives us pi over 3, 5 pi over 3. Cosine is negative 1, which gives us pi. So there are three solutions, one, two, three solutions for this equation over this interval. Okay, I'm going to show you example 4. In example 4, we have tangent of x equals 3 sine of x. And we are looking for the solution of this equation between 0 and 2 pi. Okay, so again, in this equation, we have tangent function and sine function. We would like to have something in common. So let's rewrite tangent as a sine over cosine, because then we at least have sine in common. So this is gonna give me sine of x is 3 sine x cosine of x. Please pay attention that here I'm not going to cross these two signs. Don't do that. You know why? Because in fact, when we are crossing, we are dividing. What we are doing is that we are dividing both side by side, but we cannot do that. Why? Because whenever you do division, you should be sure that that factor is never 0. However, sine can be 0. Sine of 0 is 0. Sine of pi is 0. So because this sine could be 0, we cannot divide both sides of this equation by sine. So don't get tempted to cross these two signs. Don't do that, okay? Instead, put everything on one side and factor this element or this common element of sine. So I'm going to rewrite this as sine of x minus 3 sine of x times cosine of x. So take everything to one side of the equation and then factor this common element. Sine is common, so factor this out. So from the first term, we are going to end up with 1. From the second term, we are going to end up with 3 cosine. Now you can say, now that we completed the factorization, either the first factor is 0 or the second one is 0, which this one gives me cosine equal 1/3. So sine is 0 at 0, at pi, at 2 pi, but we have to stop before 2 pi. Okay, so 0 and pi. And cosine is 1/3 at, I need to use calculator. For 1/3, I don't know, we need to use calculator. So let's see. Yes, if you use calculator to evaluate cosine inverse of 1/3, then you need to round your answer about 1.231, about 1.231. Okay, so these are the solutions. So the solutions are 0, pi, and also cosine inverse of 1/3, and we have 2 of them. When you take the cosine inverse, we have 2 of them. So that's the idea. I think you got the idea, right? So the big picture is right here. Okay, so we just use the trig identities in order to find a common element in this equation, factor it out, and when you're done with factorization, you can solve. There is also another solution, which is almost 5.5052. Okay, so there are 4 solutions. 1, 2, 3, 4. 4 solution for this equation over this range. So I think I leave the example 5 to you. I think you got the idea. Just use the trig identities and then solve this equation. That's it. So you just need to review the trig identity and then use them in combination with factoring, using quadratic formula, and then simplifying in order to solve this equation. So now you should be ready to do the exercises of this section. Thank you for watching this video. I'll see you in the next one.